this lesson is our last official lesson before we start getting ready for the test. And this lesson is going to be about implicit differentiation. And just to kind of like make sure you don't get bogged down in the fact that this sounds like it's very complicated. Essentially, up to this point, every problem that we've found the derivative for or used differentiation, which is the process of finding a derivative, we've had a equation or function where your y values are explicitly stated according to your x values. So essentially what I mean is all of our functions have been like f of x equals, and then everything that's x is on the right side. Or another way to put it is y equals, and everything on the right side is where your variable x is. Now, the reason that this is called implicit differentiation is because we can still take the derivatives of equations and functions that aren't explicitly stated y in terms of x. So this slide here are the steps we're going to solve, or steps we're going to follow to implicitly differentiate functions or equations that are stated in implicit terms. So essentially, you're going to see y's and x's, on either side. Okay. So we're going to follow this process, and we'll take a look to see how to do this first one. All right. So the way we're going to do this, you'll notice, as I said, that we have x squared plus y squared equals 25. So up until this point, this problem would have said something like y equals, and everything on the right side is where you find the x. But it doesn't. So we're going to find the derivative here. So dy dx is going to be d dx of x squared plus y squared equals d dx of 25. Okay? Now, when we did this, up to this point, when we do the derivative with x, you just can use the power rule. So the derivative of x squared is 2x. But here is kind of the major difference, and I'll do a little sidebar here. Right? So we have the ddx of y squared. Okay? So using the power rule, you have 2y to the first power. Okay? But here's the thing about using the derivative with respect to x. This is not with respect to y. So because it's with respect to x, we actually have to then include dy dx after this piece. So it's kind of like the chain rule shows up in this piece of y. So we have 2y times dy over dx. Okay, so that's kind of the main difference you'll see in this lesson, is that whenever you're differentiating with respect to x and you're doing it with the y variable, you have to include that dy over dx. And then on the right side of the equation, we have d over dx, or d dx of 25, which is going to be 0. All right, now, after this, I'm going to be solving for dy dx, right? Ultimately, that's what I'm going to be finding here. So I'm going to move the 2x over. So I get 2y times dy over dx equals negative 2x. Now I'm going to divide both sides by 2y. So my dy dx, when I simplify, right, is going to be the opposite of x over y. So this is dy dx. So that was your first example of what's called implicit differentiation. So really the main thing, the most confusing thing here, is that whenever you do the derivative of the letter y, like here, the derivative of y squared, you have to include that dy dx piece. All right, so keep that in mind moving forward. The next problem. All right, the next problem says, assuming that y is defined implicitly by this equation, let's find dy dx. So again, we're going to find the derivative of x cubed x cubed sine y, my bad, plus y equals the derivative of 4x plus 3. Okay, now this we have is the product rule. So I'm just going to focus on the d dx of x cubed sine y first. Remember, to do this, we're doing the derivative of the first. So the derivative of x cubed is 3x squared times the original second, which is the sine of y, plus we're going to do the derivative of the second. So the derivative of sine is cosine. So cosine of y. But remember, because we have y in our argument, we have to multiply this by dy over dx, and then times the original first one, which is x cubed, plus the derivative of y is 1 times dy dx, and that equals the derivative of 4x plus 3, which is just 4. Now, at this point, the way we're going to do this is following the steps in the slide for the problem solving for this. Is we want to get everything that doesn't have dy dx to the other side so we can factor out dy dx. So I'm going to move this piece over to the other side. I'm going to move 3x sine y to the other side. So minus 3x sine of y. All right, so now I have the cosine of y times dy dx. I'll put the x cubed in front here. Plus dy dx equals 4 minus 3x times the sine of y. Now I'm going to factor out the dy dx. So I have dy dx times x cubed times the cosine of y plus 1, which equals 4 minus 3x sine y. And so to solve for dy dx, we're going to divide both sides by this remaining piece on the left. So divide by x cubed cosine y plus 1. All right, and so my answer for dy dx is going to be that fraction. So 4 minus 3x times the sine of y all over x cubed cosine of y plus 1. And that's it. That's kind of the main process here of implicit differentiation. Okay, now it wants us to find a second derivative of x squared plus y squared equals 25. Now, if you notice, the very first problem we did was example 3.68. We found the first derivative of x squared plus y squared equals 25. So I'm going to write that down right here, that dy dx is equal to the opposite of x over y. So to find the second derivative, so that's d squared y over dx squared, we're going to do d dx of the opposite of x over y. So I'm going to find the derivative of negative x over y. Now, when you do this, right, what I'm really going to be doing is finding the opposite of, or like negative 1 times the derivative of x over y. The reason I can do that is because of my constant multiple rule. I don't want to deal with that negative. That negative can be like in front of the fraction. So it's just going to be the opposite of whatever I get at the end. Now, this is going to be the quotient rule. All right, I have x over y. So the derivative of the numerator is 1 times the denominator is y minus the derivative of the denominator, which is the derivative of y, is dy dx times the original numerator, which is x, all over y squared. Okay? Now at this point, I'm going to replace, kind of this is the reason I wrote it, but at this point I'm going to replace dy dx, right, which is right here, with what it's equal to, which is the opposite of x over y. Okay? And I should actually, I'm going to do that in a second. I'll write this negative sign down here because this negative sign is from that negative 1. Okay? So let's go and replace it. I'll leave that negative with the numerator. So the opposite of y minus, and we have negative x over y times x all over y squared. Okay, a lot going on here. I'm going to keep simplifying. I'm going to distribute my negative, get negative y. All right, then I'm going to write a negative times a negative is plus, and that's going to be x times x, which is x squared over y, all over y squared. I'm going to simplify the numerator, right? If I get a common denominator of y, that's going to be negative y squared plus x squared over y, and then divided by y squared, which is times 1 over y squared. Okay? And then if I finish this, it's going to be negative y squared plus x squared all over y cubed. I'm going to pause for a second because I think I made a mistake. I just want to confirm that I have it correctly. Okay, so I found my mistake. When I was distributing my negative right here on this step, what happened is that I did the negative times the y, that's correct. But this subtraction of a negative becomes addition, but the negative of that, the opposite of addition, should have stayed subtraction. So this should still be subtraction. All right, so it's actually going to end up being negative y squared minus x squared over y cubed. Now this is the answer that I'm saying for the second derivative of dy dx. All right, okay, let's try this one here. Finding the equation of the line tangent to the curve, x squared plus y squared equals 25 at the point 3, 4. Now remember, the moment you see that you're trying to find a tangent line to anything, a circle, curve, whatever, is you need to use point slope form. So I need to have a point and a slope. I already have a point. So usually in the last problems that we've done, you've had to use the x given to you to plug into the function to find the y, but they've actually given us the point. So we're good there. So I need to find the slope. So first thing I need to have is the derivative of dy dx. But remember, this is the same circle that we've been dealing with in 2 out of the first 3 examples. We already said that the derivative of x squared plus y squared equals 25 is this same thing, negative x over y. So this is negative x over y. So to find the slope, I'm going to plug in for x, I'm going to plug in 3, and for y, I'm plugging in negative 4. So the slope here for my tangent line is going to be positive 3/4. So now if I use point slope form, I can find out my equation of my tangent line to this circle. So y plus 4 equals 3/4 times x minus 3. So y plus 4 equals 3/4 x minus 9/4. I'm going to move the 4 over, all right, by subtracting 4. So getting a denominator for that 16/4. So negative 9/4 minus 16/4 is negative 25/4. So this is my tangent line. Now I'm going to go to Desmos to show you everything we just did to connect it for your brain here. All right, but essentially we're going to have a circle, x squared plus y squared equals 25. So here's Desmos. We've got x squared plus y squared equals 25. And then our line that we just found that's tangent to this is 3/4 x minus 25/4. All right, so if you look, my blue line that I just graphed is tangent to this circle at 3, negative 4. So essentially that's what we did with the calculus and the algebra, and there it is graphing. All right, let's keep going from here. Now, this next one is very similar to what we just did, but we've got a lot of work to do because we need to find the derivative of this line, of this graph, which is called the leaf or folium of Descartes. So I'm going to do d dx of y cubed plus x cubed minus 3xy equals d dx of 0. Okay. Now, I'm going to split this up to kind of show a little bit more work here. But I'm doing the d dx of y cubed plus d dx of x cubed. And then watch how I do this. I'm going to do minus 3 times the d dx of xy. All right, and that's going to just be equal to 0 because the derivative of 0 is 0. All right, so hopefully you notice I just used the constant multiple rule to move to the front. So then I can use my product rule for x and y. All right, let's start with the y cubed. Using the power rule, that's 3y squared, but we have dy dx because it is the letter y, plus 3x squared. And then here we have minus 3 times whatever is going to be with my product rule. So I have the derivative of the first, right? Derivative of x is just 1. So 1 times y plus the derivative of the second, which is dy dx times the original first, which is x. All right, so I'm going to distribute that 3. So 3y squared, I need to write equals 0. Keep forgetting that. dy dx plus 3x squared. Here's my distribution. So minus 3y, and then minus 3x dy dx. So like the problem solving step said at one of the first slides, if it doesn't have dy dx, it's going to the other side. If it has dy dx, it's staying on the left side. So copy down your stuff that has dy dx. You'll notice that I do have a second slide I'm going to be using here in a moment. So I'm going to be moving over there once I finish finding this dy dx. Okay, and then that's going to be equal to, if I move over the 3x squared, it becomes negative 3x squared. And if I move over a minus 3y, it's going to be a positive 3y. Factor out the dy dx. That leaves you with 3y squared minus 3x equals that negative 3x squared plus 3y. So to solve for dy dx, I'm going to divide both sides by 3y squared minus 3x. All right, and that's going to be my derivative. Okay, now remember, we are not done yet. I just found the derivative, excuse me. Now we're finding the equation of a tangent line. So I'm going to move to the next slide, and I need to take my derivative, which is this whole fraction here, and I need to plug in the point they gave me for x and y. So I'm going to rewrite it. So I'm going to rewrite it up here as dy dx equals negative 3x squared plus 3y all over 3y squared minus 3x. And now I'm going to plug in wherever I see x and y, I'm going to plug in 3/2. They just happen to be the same. So that's going to be equal to negative 3 times 3/2 squared plus 3 times 3/2 all over 3 times 3/2 squared minus 3 times 3/2. If you wanted to save yourself some time, you could plug all this into decimals and get it for you. Right now, I'm going to keep going without a calculator. 3/2 squared is 9/4. All right, so that, and then 3 times 3/2 is going to be 9/2 all over. Again, 3/2 squared is 9/4. And that's going to be minus 9/2. Keep going. If I multiply that, I get negative 27/4 plus 9/2 divided by 27/4 minus 9/2. Okay, getting a common denominator is going to give me to be 18/4. Negative 27 plus 18 is negative 9. So negative 9/4 divided by, and 27/4 minus 18/4 is going to be by that. So again, if you divide the same number by the same number, you get 1. But since it's a negative divided by a positive, this is going to be negative 1. So my slope, right, my slope of my line is going to be negative 1. All right, now I'm going to use point slope form. All right, I'm going to use point slope form. Remember, my points are 3/2 for both. So y minus 3/2 equals negative 1 times x minus 3/2. Distribute the negative 1. And then move the 3/2 over with addition. And 3/2 plus 3/2 is going to be 6/2, which is plus 3. So here is my answer. Again, I'm going to type all this in so you can see visually what we just did with the calculus and the algebra. All right, so the first thing I'm going to do is I'm going to graph Descartes' folium or leaf as y cubed plus x cubed minus 3xy equals 0. Let's see, y cubed plus x cubed minus 3xy equals 0. So there is the leaf or folium. And then our tangent line is going to be negative x plus 3. So there's our purple tangent line. And then the point that it's tangent to is, what kind? It was 3/2 and 3/2, right? Yeah, let me see if I can plot that. Y equals 3/2. There we go. So you can see right there is where they meet, the purple and the green. Okay? All right, let's do one more and then we'll be all finished. All right, so this last one is going to feel very similar to what we just did, just another kind of example here of using implicit differentiation. A big word problem, though, that says we have a rocket is traveling in an elliptical orbit. So this is the equation for an ellipse, 4x squared plus 25y squared equals 100. The rocket's going to fire missiles along lines tangent to its path, and the object of the game is to destroy an incoming asteroid traveling along the positive x-axis toward the origin. If the rocket fires a missile when it is located at this point 3,8/5, where will it intersect the x-axis? So essentially, what I think of when I read this problem is they want me to find the line that's tangent to this ellipse, all right, going through the point 3,8/5, but the extra step, the thing we haven't done yet, is once we find that tangent line, we need to figure out where it's going to intersect the x-axis. All right, because that's where the asteroids are traveling on the x-axis. All right, so let's start out by finding, since I already know my point, right? I need point slope form. I need to find the slope. So I'm going to find the derivative of 4x squared plus 25y squared equals 100. All right? So if I do the derivative of 4x squared, I get 8x. And then the derivative of 25y squared with respect to x is going to be 50y times dy dx. And the derivative of 100 is 0. Move over the stuff that doesn't have dy dx. That's going to be negative 8x. And divide both sides by 50y. And you get dy dx equals, let's see, that's going to divide by 4, I believe. Let's see, is that right? No, by 2 will be 4/25. Yeah, by 2. So it's going to be negative 4x over 25y. So this is the derivative. All right. Now I'm going to keep going underneath here since I have room. To find the slope, I'm going to plug in, for x, I'm plugging in 3. All right, so I'm going to plug in negative 4 times 3 all over 25 times y, which is 8/5. All right, that's negative 12 over 25 times 8/5. 25 divided by 5 is 5, so 5 times 8 is 40. So if we reduce that, we're going to get, let's see, you can divide by 4, get negative 3/10. So this is the slope. All right, so now I'm going to use my point, which is 3,8/5, and my slope, which is negative 3/10, to use point slope form. So y minus y sub 1 equals m times x minus x sub 1. So y minus 8/5 equals negative 3/10 times x minus 3. I'm going to zoom in there. Y minus 8/5 equals negative 3/10 x plus 9/10. Move the 8/5 over with addition and change the common denominator to be 10. So that's going to be 16/10. 9 plus 16 is 25, so that's plus 25/10. So this is my line that is tangent to this ellipse at the point 3,8/5. But again, we need to figure out, where does this line cross the x-axis? So we're trying to find the x-intercept. And hopefully you remember from your days in algebra that x-intercepts are x comma 0. So the y must be 0. So to finish this problem, I'm going to set this equation equal to 0. All right, so I'm going to move the 25/10 to the other side, equals negative 3/10 x. I'm going to multiply both sides by negative 10/3. So So I'm going to get x equals, that's going to be a positive. The 10s are going to cross out, positive 25 thirds. Hopefully you're appreciating the music in the background. I'm not sure what's going on in the hallway. Anyway, I'm not going to stress about it because we're done. Now, let me show you kind of everything I just did in those 2 slides. Again, I want you to, I know the implicit differentiation is tricky and it's new, but really the whole process here, the steps, that's not new, right? We've been doing it for weeks. So I'm going to plug in to Desmos the equation for this ellipse. And then I'm going to draw the line. I'm not going to draw it. Desmos is going to draw the line. And then I'm going to show you where it crosses the x-axis. So I have 4x squared plus 25y squared equals 100. All right, so 4x squared plus 25y squared equals 100. So there's the ellipse. Our line is negative 3/10 x, negative 3/10 x plus 25 tenths. So there's the line, and there it is, tangent to 3, 8/5. 8 divided by 5 is 1.6. Again, that's not the answer, right? The answer is where it crosses the x-axis, which is 8.3 repeating. And we said our answer was 25 thirds, and 25 thirds is 8.3 repeating. So you can see that those match. All right, so that's it, guys. We finished our lessons. We're going to start reviewing for the test. I know it's going to be fun. You'll enjoy it. Hopefully you have a chance to practice these homeworks. Get them in as soon as you can so you can get some feedback. See ya.